In this project, I have built a machine learning model to predict house prices using different features of houses. Where we can see objectives of this particular project. Uh, there we come to first step, importing libraries. First, I imported all the required libraries like pandas, numpy, matplotlib, seaborn, and sklearn. These are used for data processing, visualization, and building machine learning models. Next, we loaded the dataset where I loaded the dataset using pandas and then I displayed the first few rows of the to understand how the data looks like. Here we can see like this a data looks like. Next, basic information about the datasets such as dataset check. We can give a title. Then I check the dataset using an info and describe function. This helps me understand the structured data type and summary statistics. It also checks for missing values. Here we can see every operation which are been performed. Here we can see info, describe, and initial, like fetching the data. Next, we move on to handling missing values. I handle the missing values by removing them using dropdown to ensure clean data. Here we can see I have used the df.dropdown to ensure a clean data set, which we can see here. Next, I removed the duplicate values like duplicate records to avoid repeated data affecting the model. Here also we have used here the drop duplicates and duplicate values have been dropped or removed. Next, univariate analysis has been performed using histogram to understand the distribution of each features, where we can see here the distribution feature histogram which has been performed using distribution feature. We have used matplotlib to plot these graphs in univariate analysis. Next, in bivariate analysis, I have performed bivariate analysis using scatter plots to understand the better relationship between features and house prices. Like we can see here x is equal to square footage and y is equal to house prices, and we can see a scatter plot which shows a relationship between the features and house prices. Next, correlation heat map also has been performed to see how different features are related to each other and to the target variables. Here we can see correlation heat map. Next, outlier handling. Detecting and handling the outlier was one of the major part where I handled this outlier using the higher IQR method. IQR means interquartile range. Outliers are extreme values that can negatively affect the model, so removing them improves performance. Here we can see the box plots which have been performed in this outliers handling, and we have used interquartile range to perform this outlier handling. Here we can see the final output of this, and we have also checked remaining rows, like after this performing outlier handling we have verified it also. Next, applying encoding, where in encoding I check for categorical variables since all features were numerically encoded was not required. Here also mentioned that no categorical column were found in dataset, so encoding was not required. Why? Because there was no categorical variables in this particular dataset. Next, we move on to log transformation. In that, I applied log transformation on the house price to reduce skewness and improve model performance. Here we can see table after performing log transformation, and we have also plotted a histogram plot where it shows after a log transformation uh, how the graph looks like. Next, we have performed a dot describe function here also to verify once after log transformation. And next, we move on to train and test split, where I split the dataset into training and testing sets using an 80 to 20 ratio to evaluate the model. We have evaluated the model by training it, and applying feature scaling is also one of the important tasks to be performed here. I applied it using standard scalar to normalize the feature values. This is important especially for KNN since it depends on distance. Where while trialing models like KNN regressor, it's very important to apply feature scaling, as I mentioned. Next, model training was done in linear regression and for KNN regression. I trained linear regression model which assume a linear relationship between features and targets. In linear regression, it assumes a relationship was between features and targets. In KNN, which predicts value based on the nearest data points. In KNN, as usual, it predicts the value based on nearest data points. Here we can see how we have trained the data models. Next, model evaluation was also been done with these steps, which you can see here. Finally, I evaluated both models using metric like MAE, means mean absolute error, MSE, mean squared error, and RMSE, root mean squared error, and MAPE and R2 score and adjusted R2, where lower error values and higher R square indicates better performance in this model evaluation. Here we can see how model is being evaluated. Next, model comparison table was also been shown here. We have compared both the models, linear regression and KNN regression, and we have performed cross-validation for all the models to ensure that it is being trained correctly. So next, we have also plotted actual with predicted plots. Here we can see linear regression like predicted price and actual price value has been showed in this scatter plot. And next, we have compared actual and predicted house price also, where we can see actual and predicted price comparison, and error comparison chart also been done using model comparison, where values and metric are being compared. Here you can see that the orange color graph is linear regression and blue color is sorry orange color is KNN regression and blue color is linear regression. Next, final conclusion, where I successfully built a machine learning model for predicting house prices by applying data pre-processing, feature scaling, and model training. I improved the performance of the model by also proving the best model. Here you can see linear regression. Thank you.